Welcome to Lecture 16, Unit 3. This is Probability and Counting Rules. My name is Jorge. So in this lecture, what we're going to talk about is just finding the probability of an event using the counting rules. So essentially what we're going to be using is the combination rules, and then towards the end we use a permutation rule. So the first example is, let's find the probability of getting 4 aces when 5 cards are drawn from an ordinary deck of cards. So the first thing is that we're going to go ahead, we have to find how many ways can I choose 5 cards out of 52. So that's going to be our denominator. The next thing is that there's only one way to choose 4 cards out of 4, so 4 aces. So that would be 4 choose 4. And then, of course, I have 48 possibilities for the 5th card. So what's going to happen is that my denominator then becomes the ways that I can choose the 4 aces times the how many possibilities I have for the 5th card divided by my denominator, which is 52 choose 5. And then you can see that it is a pretty small possibility that if you deal 5 cards that you get 4 aces. So the next thing is a box contains 24 transistors, 4 of which are defective. Now, if 4 are sold at random, find the following probability. So we're going to go ahead and find exactly 2 are defective, none is defective, all are defective, or at least 1 is defective. So the first example is exactly 2 are defective. So again, we have our denominator is going to be 24 choose 4. So we have 24 to choose from, and we're choosing 4 out of the 24. Now here, we have 4 of them that are defective, but we only want 2, so it's going to be 4 choose 2 to find out how many are defective. And then, of course, what's left over is going to be 20 choose 2, because I have 24 total, 20 are defective, 20 are not defective, 4 are defective, and then, of course, I'm choosing 4 actually, so 2 and 2. So then my numerator then is the 4 choose 2 times the 20 choose 2 divided by the 24 choose 4. And then you see that it's about 11%. So I have an 11% chance of choosing and getting exactly 2 that are defective. All right, what about none is defective? So none is defective. Well, there's 20 of them that are not defective. So a 20 choose 4 is my numerator, 24 choose 4 is my denominator, and then I get about a 46% chance. What about all are defective? Well, in this one here, I have that, again, my denominator is still a 24 choose 4, so you can see a pattern here developing. 4 of them are defective, so there's only one way that I can choose all 4 defective. So 4 choose 4 divided by 24 choose 4 gives us a pretty small possibility that all of them are defective. And then the last one in this example is at least 1 is defective. So this is just simply the complement of that none are defective. So it's going to be 1 minus the 20 choose 4 over 24 choose 4, which gives us about a 54% chance of choosing, when we choose 4, that at least 1 of them is defective. All right, here's another example. A store has 6 TV graphic magazines and 8 News Times magazines on the counter. Two customers purchase a magazine. Find the probability that 1 of each magazine was purchased. So the first thing is we have 14 choose 2. So I have 8 magazines graphic and 8 News Times, so that's 14. I'm choosing 2. So 14 choose 2 is going to be my denominator. So I have 6 choose 1 for the TV graphic, and I have 8 choose 1 for the News Time. So the 6 choose 1 and the 8 choose 1 become my denominator, and then the 14 choose 2 is my numerator, and my 14 choose 2 is my denominator, and that gives about a 53% chance. And the last example is a combination lock consists of 26 letters of the alphabet. If a 3-letter combination is needed, find the probability that the combination will consist of the letters A, B, C in that order. Now, the same letter can be used more than once. So the question is this combination lock actually a combination or a permutation? It actually turns out to be a permutation because order is not important. So basically, I have 26 for the first letter, 26 for the second letter, 26 for the third letter, which gives me 17,576. That becomes my denominator. So the probability of getting A, B, C would be 1 over 17,576. And then the last example would be, here we have 8 married couples in a tennis club. If one man and one woman are selected at random to plan the summer tournament, find the probability that they are married to each other. So basically we have 64 possibilities, right? So for one man and one woman. And so then 8 divided by 64, 64 becomes my denominator. And then since I essentially, what's the probability that they're married to each other? Well, there's a 1 in 8 chance that when I choose the man and the woman, that they're actually married to each other. And that's the end of lecture 16, unit 3. Thank you.